Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating System. We are in the process of learning about process synchronization concept. In our last lecture, we learned about the basic background of what is the need of having process synchronization. Where we have understood through producer consumer problem, we have understood if there is no proper synchronization between the process execution, it may lead to race condition. So there we have understood, like, if multiple processes are accessing some shared variables simultaneously, then the instructions need to be executed in a proper way, otherwise it may lead to a race condition. So we understood, like, there should be some security or locking mechanism for the shared variables. So that can be resolved by using this critical section problem. So what is this critical section problem is? In this, what are all the shared variables that are accessible by multiple processes that need to be kept in a section which is referred as a critical section, and these shared variables are your global variables or some global files that can be accessed. So, part of your program where shared variables need to be accessed are called as a critical section. Make a note of this one, all of you. So, critical section is nothing but part of the program where shared memory, it can be the shared memory can be your variables, global variables, or your files. All those things comes under shared memory. So part of the program where shared memory need to be accessed, so that part of the program is referred as critical section. Critical section is nothing but this one. Now, one simple example is, do you remember in the last video, we have used a variable called a count variable. Do you remember? We have used that variable called count variable, where this count variable can be incremented by producer. By producer, it will be done, and by consumer, it will be done by count equal to count minus 1. Where when a producer is producing an item, then that item has to be placed in the buffer and then the count has to be incremented. And when a consumer is taking an item from the buffer, then the count has to be decremented. I hope you all could recollect that one. There we have understood a problem, right? Because this count operation can be divided into some sub instructions where registers will be involved, and while doing that, that may lead to, if these two are not executed in a proper way, it may lead to a race condition. Why it is leading to a race condition? Because this variable, which is count variable, is our shared variable. This count variable is a shared variable. So this shared variable, if it is accessible, now if this shared variable, which is our common shared memory, if it is kept in a critical section, this is called a critical section. Now, if producer is using this critical section, then you should have a scenario where the consumer should not be allowed to use this variable. I'll repeat once again in more detailed way. Let us consider this is the critical section. In this critical section, you have a variable called count. Now, producer, this is our critical section. Now, if producer is using this critical section variable, then the consumer has to wait until the work of this producer using this count variable is done. That is called a synchronization. I hope you all are understanding. In the last video, we have understood where this producer and consumer are using parallelly that variable, and because of that, we got this race condition. Now, if you have this constraint of until and unless the work of the producer using this count variable is done, this consumer has to wait until the consumer can't use this count variable. So there will not be any chance of getting this race condition. Inappropriate or inconsistent data cannot be stored. Right. Now, how to achieve this one, we will understand today. So today's critical section problem is how we can place the shared variable into this critical section. Right. Now, to achieve that one, what are all the things need to be done and what are all the solutions that are provided for this critical section problem, we will understand in this video. So there are two solutions provided for this critical section problem. Make a note, all of you. Two solutions are given. CS means critical section problem. First solution is called as software solution, which is referred as Peterson's solutions. Peterson's solution. We will understand in detail what is the software solution is. And the second solution for this critical section problem is hardware solution. And this hardware solution is also called as synchronization hardware. So these are the two solutions existing for our critical section problem. Software solution and hardware solution. So in our next two videos, we will be understanding in detail about this, how a problem solution, critical section problem solution can be given by Peterson, which is called a software solution, and then hardware solution, where in predefined set of instructions are available, how to adopt that one also we will see. But before proceeding with these two solutions, always we need to remember, like whatever the solution may be, the solution for the critical section problem must satisfy three requirements. That means these solutions, whatever we have here, that should satisfy three requirements. Note down, all of you, what are the three requirements. The first requirement is called as mutual exclusion. First, note down the three requirements. We'll have a discussion about what are these three. Mutual exclusion, second one is progress, and third one is bounded weight. So what are these three requirements? Let us understand. First one, let us see about mutual exclusion. Mutual exclusion is nothing but suppose I already told you we have a process like this. Let us consider this is a process. This is our critical section. Let us consider this is our critical section. In this critical section, let us consider we have a variable called count. Okay, now let us consider we have two processes, P1 and P2. Now suppose if P1 is using this variable, then until and unless P1 completes its work with this C variable, which is placed in the critical section, if P2 wants to use that critical section, then P2 is not allowed inside this critical section. It has to wait. That is called mutual exclusion. Once P1 comes out of this critical section, then P2 will be allowed into this critical section to use this C variable. So that is called mutual exclusion. So mutual exclusion is nothing but at a particular time only one process should be in the critical section. So make a note of that one, all of you. Mutual exclusion is nothing but at one time only one process should be in critical section. I hope you all are clear with this mutual exclusion concept. Right? Now, next, let us see about the second requirement that has to be followed for giving a solution to the critical section problem. That is progress. So, keep your heading, all of you, progress. Now, progress is nothing but suppose this is a critical section problem. Let me take one example. This is the critical section. Okay. Now, no process is there in this critical section, and we have a set of process like P1, P2, P3, P4, so on. These are all some set of process. Now, which process has to enter into this critical section? That decision has to be done in a finite amount of time. So the decision process should be taken in less amount of time. There should not be, it should not be an infinite loop taking time to decide which process has to go into the critical section. In a finite amount of time, if the critical section is free, no process is in this critical section, then if some processes are waiting to enter into the critical section, then decision between or decision among these process which has to be given the critical section is to be done in fixed amount of time. That is called as a progress. So note down, all of you, decision should be done in fixed amount of time. This is about progress. The last requirement that has to be satisfied is bounded wait. Note down that one. Let us have a discussion about this bounded wait. Bounded waiting. Bounded waiting is nothing but consider this is the critical section. Now two processes wants to enter into this critical section P1 and P2. Okay. So as per some algorithm has been applied and this is our critical section, and this process has got the chance and it enter into the critical section. Okay, now P1 has completed its task and it has been removed now. Now it has been removed, and again P1 wants to use this critical section. Okay, Now again P1 wants to use the critical section and P2 also wants to use this critical section. Then again the P1 has been selected and it has been sent into the critical section. Now after its work is done, again P1 wants to use the critical section, P2 also wants to use the critical section. Again P1 has given the chance to enter into the critical section. If you observe the scenario here, what has happened is always P1 is only getting the chance to execute this process, to execute or to use the variables that are available in our critical section. But that should not happen. So bounded wait refers there should be a limit or there should be a bound where the number of times that process wants to enter into the critical section is to be limited if any other process is waiting to enter into the critical section. Always we should, if P1 and P2 both are requesting to enter into the critical section, always P1 should not be given a chance to enter into the critical section. P2 also need to be given a chance to enter into the critical section. So there should be a bound into entering into the critical section, the number of times to use this critical section. I hope you all are understanding. So this is about bounded wait. So whenever you are giving any solution to a critical section problem, that critical section problem can be your hardware solution or a software solution. These two solutions must satisfy these three requirements. They are satisfying, but in future if you are trying to give any critical section critical section problem solution, then make sure like it is giving or it is satisfying mutual exclusion. That means only one process should be in the critical section, and progress. The decision should be done in fixed amount of time, and bounded wait. The number of times a process entering into the critical section is to be limited if any other process is requesting to enter into the critical section. I hope you all are clear with these requirements. Now, whenever you want to give any solution to the critical section problem, what type of structure you need to follow? So keep a note of that one, all of you. General structure for the critical section problem. This is the general structure that has to be followed both by the hardware solution or a software solution or any solution that you create. So the general structure of critical section is like this. It will have a while condition which will be always true, and in this we will have different types or different parts of information. First part of information is called as entry section. There should be some lines of code which will take care of this entry section. We will have a discussion about that. First note down this one, all of you. And then you will have critical section code, and then you should have exit section, and finally after exit section the remaining code of your program should be included. So this is the general structure that has to be followed by any solution to the critical section problem. So the structure is you will have while some true always, and then it should have some entry section where the lines of code are required for this entry section, and then you will have exit section. In between entry and exit section, critical section. Now what actually these sections are? So if you observe here, there are three parts of things are there. What are the three parts? This is the first part, this is the second part, and this is the third part. The first part, which is your entry section, this entry section will contain some code. Entry section will contain some code which will help, like, let us consider one simple example in entry section. Let us consider we have two processes P1 and P2. Now, P1 started its execution. Now, in entry section, what happens? It will contain some code which will help a particular process to check whether any other process is already in the critical section or not. If any other process is already in the critical section, then the present process that is requesting to enter into the critical section has to wait. Suppose in this example, P1 got the chance first. Now it will execute this code. This code will help us to check whether any other process is there in the critical section. No one is there till now. So it will go into that section. Now that code, how to write, what is this code, that depends upon the type of solution you are giving. Okay, all right. Now P1 is there. Now P2 will come. P2 will come into the entry section. Now P2, what it does, it will check this entry section P2, it will execute. Now this code will be executed by P2. This code, what it does, it will check whether any other process is there in the critical section. Yes, already we have P1 in the critical section, then P2 has to wait. Is that clear? Now P1, I'll repeat once again. If no other process is there in the critical section, then P1 can enter into the critical section, and what it does? It can enter and it will perform entry section lock. It will lock that entry section so that any other process, if it comes, in our case P2, it has to wait until P1 unlocks this one. Now, when that unlocking will happen, P1, after performing its work in the critical section, it will come to the exit section. In this exit section, unlocking will be done. Now, what is the meaning of unlocking is, once the unlocking is done, it means any process that is waiting in the entry section which has been locked here, in our case, it is P2, can now enter into the critical section because P1 is not there. Now P2 can enter into this critical section. Got it, all of you? So this critical section, what happens if one process is entered into the critical section, no other process is allowed to enter into the critical section. So the entry and exit section will help us in maintaining that mutual exclusion concept, where in this case, P1, if it is already there, P2 has been locked. Once P1 is unlocked, P2 is entering into the critical section. Got it? This is how this general structure has to be followed for giving a solution to the critical section problem. I hope you all are clear with this simple structure of the critical section problem. Whatever the solution may be, it can be a hardware solution or it can be a software solution. These two solutions, Peterson solutions and synchronization hardware, will follow this simple structure. In our future next two classes, we will be understanding what kind of entry section they have written to lock that one, what kind of exit section they have written, what kind of code they have written as part of exit section, we will be understanding. You all know what is critical section. Critical section is nothing but the global variables will be kept here, right? Or a common variable or a shared variable or shared things that will be used both commonly by P1 and P2 will be kept here. Okay, if P1 is using, P2 cannot use. If P1 work is done, then P2 can use that one alternatively. Right. So this is about critical section problem. I hope you all are clear what is critical section problem is, right? And how many ways a solution can be given and what kind of requirements need to be solved. Let us all meet in the next lecture. In the next lecture, we will see about Peterson's solution. Until then, thank you all of you.